Have you ever wondered how long humans can live? Could AI-powered epigenetics be the key to extending human longevity by 2050? Welcome to the intriguing world of science, where the impossible becomes possible, and the future is closer than we think. Today, we're about to embark on an extraordinary journey into the realm of AI-powered epigenetics, and its potential to revolutionize human longevity by the year 2050. At the heart of our exploration are three key concepts: DNA, epigenetics, and artificial intelligence. DNA is the blueprint that designs who we are. It's like the hardware of a computer, hardwired into every cell of our bodies. But what if I told you there's also a software at play? That's where epigenetics comes in. It's a layer of control that tells our genes when, where, and how loudly to speak. It's influenced by everything from what we eat to how much we sleep, to the air we breathe. Now imagine a super advanced software developer, capable of analyzing complex patterns and making decisions at an astonishing speed. That's artificial intelligence, or AI, the third pillar of our discussion today. AI has the potential to optimize our software, our epigenetics, to improve health and longevity. Think of your body's epigenetics as software that's continuously updated to respond to new challenges like environmental changes or diseases. AI can be thought of as the tool that delivers these critical updates, enhancing our resilience to diseases and potentially extending our lifespan. But how does AI achieve this? It harnesses vast amounts of genetic data, identifies beneficial and harmful epigenetic changes, and delivers firmware updates to our biological systems. The result? A future where diseases could be preemptively corrected at the epigenetic level, and aging could be dramatically slowed down. So, buckle up as we dive into the world of AI-powered epigenetics, and its potential to revolutionize human longevity. We're about to traverse a landscape of scientific innovation, where the boundaries of human lifespan are pushed, and the definitions of aging are rewritten. Let's embark on this journey together, and explore the future of human longevity by 2050. To understand how AI-powered epigenetics could impact human longevity, we first need to grasp two complex concepts: DNA and epigenetics. Let's start with DNA. Picture DNA as the blueprint of life. It's a bit like the hardware in your computer, hardwired into every single cell in your body, dictating the characteristics that make you, well, you. From the color of your eyes, to your height, to your predisposition to certain health conditions, it's all mapped out in your DNA. But let's not forget about epigenetics. If DNA is the hardware, then epigenetics is the software. This is the layer of control that tells our genes when to switch on, when to switch off, and how loudly they should express themselves. It's like the director of a play, cueing the actors, our genes, when to enter the stage, when to exit, and how forcefully they should deliver their lines. What's fascinating is that while our DNA remains essentially the same throughout our lives, our epigenetics can change. And these changes can be influenced by a variety of factors, from the food we consume to the amount of sleep we get, to the air we breathe. It's a dynamic system, constantly adapting and responding to our environment. So we have our DNA, the hardware, and our epigenetics, the software. But where does AI fit into this? Imagine, if you will, artificial intelligence as the world's most advanced software developer. It's capable of analyzing complex patterns, making decisions, and operating at speeds that are simply beyond human capabilities. We're talking about a system that can sift through vast amounts of genetic data to identify beneficial epigenetic changes and discard the harmful ones. Think of it this way. Your body's epigenetic software is constantly being updated to respond to new challenges. These could be environmental changes, diseases, or even the aging process itself. Now imagine AI as the tool that delivers these critical updates. It's like having a personal software developer for your body, optimizing your software to improve health and longevity. So, what we're looking at here is a future where AI can use epigenetic data to deliver firmware updates to our biological systems. These updates could theoretically reverse harmful epigenetic modifications, promote healthy aging, and enhance our resilience to diseases. So, DNA and epigenetics are like the hardware and software of our bodies, respectively. And AI? That's the super smart software developer, using epigenetic data to optimize our health and potentially extend our lifespans. It's an exciting future, to be sure. But as we'll discuss later, it's also a future that comes with its own set of challenges and ethical considerations. But for now, let's revel in the possibilities. Because who knows? By 2050, we could be living in a world where aging is no longer an inevitability, but a manageable condition. Artificial intelligence, or AI, is the brain behind the operation. Now you might be thinking, that sounds like something out of a sci-fi movie, but let's break it down into simpler terms. Picture AI as the world's most advanced software developer. It's got the skills, the speed, and the smarts to tackle problems that would take humans decades or even centuries to solve. Imagine you're playing a video game, but it's a game that's constantly changing. New levels are added, bugs are fixed, and the gameplay evolves based on how you play. That's similar to how our bodies work. Our epigenetics, the software of our bodies, is continuously updated to respond to new challenges, like environmental changes or diseases. Now imagine if you had an ultra-intelligent software developer who could deliver these critical updates in real time. That's AI. It can analyze complex patterns, make decisions, and deliver firmware updates to our biological systems at speeds incomparable to human capabilities. So, how does AI do this? Well, it's all about data. AI harnesses vast amounts of genetic data, analyzing it for patterns and correlations. It can identify which epigenetic changes are beneficial and which are not, and then make adjustments accordingly. But it's not all about speed. AI is also incredibly precise. It can target specific genes, turning them on or off to optimize our health. It's like having a personalized health coach who knows your body better than you do, continuously tweaking your software to ensure you're running at peak performance. The potential implications of this are tremendous. Diseases could be detected and corrected at the epigenetic level before they even become a problem. Aging could be slowed down, extending our healthy years. So, AI could potentially optimize our software or epigenetics to improve health and longevity. It's a thrilling prospect, and one that could revolutionize how we understand and approach human health and lifespan. But like any powerful technology, it comes with its own set of challenges and ethical considerations, which we'll delve into in the next segment of our journey into the future. But how exactly does AI achieve this? Well, think of AI as the world's most meticulous detective, capable of combing through vast amounts of genetic data. It's looking for patterns, clues that reveal which epigenetic changes are beneficial and which are not. It's a complex puzzle, but one that AI is uniquely equipped to solve, using advanced algorithms and machine learning techniques. Imagine a giant jigsaw puzzle where each piece represents a tiny fragment of genetic information. Individually, these pieces might not tell us much, but when they're assembled in the right order, a clearer picture emerges. This is the challenge that AI faces when deciphering the complex language of our genes. But it's not just about understanding this genetic code, it's also about modifying it in ways that can improve our health and longevity. This is where the concept of firmware updates for our biological systems comes in. Just as a software update can enhance the performance of your smartphone or laptop, AI could potentially deliver updates to our epigenetic software, optimizing our health and resilience to diseases. How, you might ask? By identifying harmful epigenetic modifications and reversing them, by distinguishing beneficial epigenetic changes and promoting them. Essentially, AI could guide our biological systems towards a state of optimal performance. It's like having a personal fitness trainer, but instead of guiding you through a workout routine, it's guiding your genes. It's telling them when to speak up, when to stay quiet, and how to adapt to new challenges. It's a proactive approach to health and longevity that's guided by the most advanced technology we have at our disposal. Of course, this is a simplified explanation. The actual process involves complex algorithms, vast databases, and cutting-edge machine learning techniques. But the underlying principle is the same. By harnessing the power of AI, we can potentially update our epigenetic software, improving our health and extending our lifespan. In essence, AI could guide beneficial epigenetic changes, promoting healthy aging and resilience to diseases. So, what could be the impact of AI-powered epigenetics on human longevity by 2050? Imagine a future where the number of candles on your birthday cake is just a number, where the concept of aging as we know it is dramatically redefined. This is the future we could be stepping into, thanks to the convergence of AI and epigenetics. The year 2050 might seem a long way off, but in the grand scheme of human evolution, it's just a blink of an eye. And yet, in this relatively short time frame, AI-powered epigenetics could potentially revolutionize human longevity. The key lies in the ability of these technologies to extend not just our lifespan, but our health span, the period of life spent in good health, free from chronic diseases. One of the most exciting predictions for the future is the possibility of preemptive disease correction. This means identifying and correcting diseases at the epigenetic level before they even manifest. With AI's ability to analyze vast amounts of genetic data, it could identify harmful epigenetic changes and reverse them, preventing diseases from taking root in the first place. Then there's the potential to slow down the aging process itself. Aging is, after all, an accumulation of epigenetic changes over time. By identifying and reversing harmful modifications, AI could theoretically slow down aging, keeping us healthier and vibrant for longer. How does the scientific community see this future? We've spoken to leading scientists and technologists who are optimistic about the role of AI in healthcare. The consensus among them is clear. By the mid-century, AI-powered epigenetic interventions could become a cornerstone of preventive medicine. These interventions could be tailored to an individual's unique genetic makeup and lifestyle, offering personalized treatments that go beyond one-size-fits-all approach. For instance, your genetic data could inform a personalized diet plan or exercise regimen designed to optimize your health and longevity. Of course, it's not all rosy. There are challenges to overcome, from ethical considerations to data privacy concerns. Not to mention the need for equitable access to these technologies to ensure that the benefits are not limited to a privileged few. But as we stand on the brink of this new era, the potential benefits are too significant to ignore. By 2050, AI-powered epigenetic interventions could become a key part of preventive medicine, tailoring treatments to an individual's genetic makeup and lifestyle. This could be our reality in the not-so-distant future, a future where we're not just living longer, but living healthier, more vibrant lives. And as we navigate this brave new world of AI and epigenetics, one thing is certain. The journey to understanding our own biology and harnessing it for our benefit is one of the most exciting adventures humanity has ever embarked upon. And you, dear listener, get to be a part of it. But with great power comes great responsibility. As we delve deeper into this revolutionary fusion of artificial intelligence and epigenetics, it's crucial to consider the ethical implications that come along with such trailblazing advancements. First and foremost, it's essential to address data privacy concerns. With AI algorithms analyzing vast amounts of genetic and epigenetic data, it's paramount to ensure the security of this sensitive information. Robust data protection measures must be put in place to prevent unauthorized access or misuse. As we step into an era of personalized medicine based on individual genetic makeup, the need for stringent data privacy cannot be overstated. Next, we must consider the ethical implications of manipulating the very codes of life. While the potential benefits are immense, we must tread with caution. The power to alter our biological firmware raises questions about the sanctity of human life and natural processes. We must ensure that these interventions are used responsibly, with a clear understanding of potential long-term effects. Moreover, the question of equitable access to these technologies comes to the fore. It's crucial that the benefits of AI-powered epigenetics are not limited to a privileged few, but are made accessible to all. After all, health and longevity are not luxuries but basic human rights. The challenge lies in creating a framework that ensures these groundbreaking technologies are distributed fairly and ethically. On a broader level, regulatory bodies, governments, and international organizations will need to collaborate to establish guidelines and regulations for the use of AI in epigenetic interventions. These policies should strike a balance between fostering innovation and ensuring ethical practices. As we contemplate these considerations, it's clear that the journey ahead is not without its challenges. But, with careful planning, ethical foresight, and a commitment to equity, we have the potential to navigate these uncharted waters successfully. As we step into this new era, the potential for AI-powered epigenetics to enhance human longevity is both thrilling and profound. By keeping our biological firmware up to date, we may look forward to a future where our bodies remain vibrant well into what used to be considered old age. The future is here, and it's brimming with possibilities. The fusion of AI and epigenetics promises a future where diseases can be preemptively corrected, aging could be dramatically slowed down, and human longevity can be significantly enhanced. It's time to embrace this future with all its challenges and opportunities. Let's step into this brave new world together, armed with knowledge, curiosity, and a commitment to ethical progress.